Welcome to Sundar's lecture. This is lecture number 6, and in this lecture we are going to see principle of duality, and there are so many laws in Boolean algebra, and as well as we are going to see some simplification of Boolean expressions, right? So what are the topics we have seen in the previous class? See, we have seen what is the operators available in Boolean algebra and the basics of Boolean algebra, right? These are all three operators. And then we have gone for truth table and the importance of truth table, and also we have seen tautology and then fallacy, right? So then we have also taken some expressions to prove that these expressions follows the truth table, and the truth table will give you all ideas what the expression will do, and if inputs are given, and those expressions can be how those expressions are doing with the Boolean expressions, right? So next thing in this particular class, see, this one I have given you as a homework, but this one we are actually going to prove now. Anyhow, this is a De Morgan's theorem, and I will explain you what does this one exactly means in this particular class, and also you can even you can draw the truth table. Anyhow, I will draw the truth table. This is x and then y, right? There are two inputs are there, so it will be 0 0 0 1 1 0 1 1, right? So this one, what you need to find, x dash and y dash you separately need, so x dash and then y dash. So this one will be 1 1 0 0, this one will be 1 0 1 0. This is the x dash and the y dash, and you need to find what is x plus y the whole dash. So for that you need to find what is x plus y. So x plus y you need, right? So you can see this is 0, this is 1, add you, if you add these two it will be 1, if you add these two this will be also 1, and you need to find what is x plus y the whole dash, the opposite of this one, complement, 1 0 0 and then also 0, and then you need to find what is the value of x dash dot y dash. So you multiply these two, that's all. Simply you multiply these two. If you multiply these two, you will get 1. You multiply, you will get 0, and then you multiply again, it will be 0. You multiply these two, again it will be 0. And you can see this one, these two expressions, both expressions, this one as well as this one, both are same. So if you see any expressions like x plus y the whole dash, you can change that particular expression to x dash dot y dash, right? So that is the uh, thing you have to understand here, right? So now we try to get the knowledge about Boolean algebra through some postulates, or we can call it as the some laws are available, so that you can easily simplify the expressions, right? So first we will go for principle of duality. What is principle of duality? For example, if you have a function like expression like this, a plus 1 will always give you 1. For example, why they are saying that, if a is equal to 0, take this expression, a plus 1, a is equal to 0, substitute a is equal to 0, 0 plus 1 will give you what? 1. Put a is equal to 1 there, 1 plus 1 will also be 1 in Boolean algebra. So whatever it may be, if you have any plus 1 with any function, the output of that particular function will become 1. That is the one thing. So now what we are doing, this is actually an OR operator, right? This is a OR operator. This is a OR operator, and what we have done here, we have changed this OR operator to AND operator. Just we have converted this to AND operator. If you do so, exactly, this zeros and ones will be inverted. The zeros and ones will be inverted. Whatever we have done, see here, this one has been converted to 0 and then are inverted, maybe this one is changed to 0 here. This principle we generally call it as duality principle. So what the expression will be here? A dot 0 will be 0. Multiplication of anything with 0, it will give you what? Obviously it will give you the 0 value, right? So this is the principle of duality. And then these are all the theorems. These are all the theorems or laws, right? So first thing, this is the basic theorems of algebra. Properties of 0, properties of 0. So if you add 0 with this particular any Boolean variable, then that particular variable will come. A plus 0 will always give you what? A. And A dot 0, obviously it is going to become 0. Then properties of 1. So A plus 1 will give you 1 and A dot 1 will give you what? A. Right? Try to understand. If you multiply 1 with this particular variable, then that particular variable will come. These are all very basic things, very basic things. And then you see this cumulative law, A plus B can be written as what? B plus A. As well as A dot B can be written as what? B dot A. These kind of things are very simple. And then associative law, A plus B plus C can be written as what? A plus, in bracket it will be B plus C. Everything is same. And as well as what is this one? AB into C can be written as what? A into B into C. That bracket will come here. See, one thing, this one I just want to tell you. See, I will take a new thing, new page. In this particular associative law, you see, we have taken that it is A plus B, then plus C can be written as what? A plus B, this is in bracket and then plus C. See, what we can do, if you change this plus operator to multiplication operator, that will follow the same expression. Try to understand. See here, you change this particular or operator to and operator, this becomes AB, this becomes AB, and you change in bracket, and you change this particular plus operator to and operator. C, multiplication of C will be is equal to, change again in the right hand side also, you just change. This will be what? Okay. Here it is. Here I have made a mistake. This is A plus BC, right? Plus B plus C. This one, right? So what you do now? You just directly change this one. You change this is to a dot operator, and then this to dot operator. That's all. You see these two expressions here. That is what we have written here. That is what we have written here. See, try to understand. You can do that. You can do that in any expression. You can do that in any expression. Say what is distributive law? It is A into B plus C. Can be written as what? This is multiplication, right? AB plus AC. See, if you know this one, you just, here it is defaultly, you have to understand that there is a dot operator here. Even here it is a dot operator. Here it is a dot operator. Those kind of dot operators in the expression they want to show you. So you have to defaultly understand. Change this dot to plus here, this plus to dot here. Again you change this dot to plus here, this plus to dot here, this dot to plus here. See this is the expression. You can write this expression like this, right? To understand. If you have any expression, even any expression, you can change the dot to R operator in left hand side as well as in the right hand side. That will give you a different expression that will also be satisfied here. Even if you put the truth table and you verify this expression, the both answers will be same. Both answers will be same. I left it to you. You just do by yourself, right? So the next one, this one, it is A plus A bar B should be is equal to what? A plus B. That also comes under the distributive law. See this one, actually this is not a straight equation. You cannot understand straight away here. For that, what you do, I will take it to the maybe next page. What is that one? It is A plus A bar B will be is equal to what they are saying. It is A plus B, right? That is the equation. That is what I have written here. See what you do to understand things. What you do, you multiply A on both sides. A, just you multiply A plus A bar B, that is one thing, plus which is equal to A into A plus B. I have just multiplied A on the both sides. So what you will get here? This is AA plus A bar A B, right? I am multiplying, just I am multiplying. And then here it will be AA plus AB. This is the equation, right? So here what is this one? A dot A will give you A plus, what is this one? This is fallacy, right? This is fallacy. A bar dot A. That is fallacy, right? So if it is fallacy, then this will become 0. 0, right? Fallacy. I have already told you. You know, I don't need to go again. So this is equal to, you see here, this one, A dot A. What is A dot A? It is A plus AB, right? That is the equation. Here it becomes A, which is equal to, you take A commonly outside. If you take A commonly outside, what you will get? 1 plus B, right? What is 1 plus B? Now only we have seen it is 1. So this will become 1, and the final answer, it will be A is equal to A. See, try to understand. I'm just proving you. I'm just proving you why I can write this is an equivalent expression, because you may see so many places in simplification. You may see A plus A bar is equal to A plus B. We will generally write. So this equation also satisfies. This is not a straight equation. Maybe you can understand these kind of expressions, but this is not a straight equation. Try to understand. This is not a straight expression. And also this is idempotence law. It is A plus A will be is equal to always A dot A will be always is equal to A, and then absorption law, or we can generally call it as redundance law. A plus AB is equal to A. Try to understand. You take A commonly outside, what it will be? 1 plus B, and 1 plus B will become 1, so it will be A. And you change this dot to plus and plus to dot, everything will be same. In right hand side you put nothing is there, so you don't need to worry about this one. So this will be also A. And then complementary law, it will be, this is nothing but tautology, and this is nothing but fallacy, we have already seen. And then in involution law, if you take double bar to any variable, the normal variable will exist, that is this one. And then De Morgan's theorem, this is very important. Always we will use this De Morgan's theorem frequently in simplifying the equations. A plus B whole bar will be is equal to A bar dot B bar. Right? And if you know the principle of duality, you can change this plus to dot operator as well as this dot to plus operator straight away. So this equation also should satisfy, right? So A plus B the whole bar, A dot B the whole bar will be is equal to A bar plus B bar. So this one we have already seen this one. Now from here in the previous class, see this one. This is the same expression. Same. I've used a different variable. That's all. So we have seen all the postulates and the theorems, laws, everything we have seen. What we are going to do, we are just going to implement these kind of laws, right? So what we will do now, we will take a new example problems. So you see here, this is the problem. AB plus A bar B plus this one should be prove that this particular equation will be equal to A. So what we will do, we will first, what you do, you just simplify this De Morgan's theorem. Always you go for De Morgan's theorem. All other terms, all other variables you keep as it is. This is AB plus AB bar. What you do, this is this term dot, this whole term, the whole bar will be equal to what? You see here, A dot B whole bar. A dot B whole bar can be equated to A bar plus B bar, right? So this one what I can write. So this is A bar, and then there is a bar here, so it will be bar plus C bar is already there, so this can be written as plus, this is bar, which is equal to A. I have to prove this, right? So this one you just keep as it is, A plus B bar, A B bar. This double bars can be cancelled out, so this will be A plus C, which is equal to A. And then you see here, what you can do here, this is AB plus, you can bring this one inside, so this will be A B bar plus A C, A B bar C, it should be is equal to A. So what you do now, you take A commonly outside, what you will get now, this is B plus, this is A dot A, or anyhow for the first time I need to go very slowly. So this is AB plus, this can be A dot A can be written as what? A, this is B bar plus A B bar C, that should be is equal to A. And you take A commonly outside now, take this one, this is B plus B bar, and whatever it may be, if you take this one, this will be B bar C, that should be is equal to A, obviously. Why? What is this one? What is this one? This is tautology, right? Tautology. Tautology means this value will become always 1. So what is the equation you will get now? This is now will become 1 plus b bar c, which is equal to a. See, 1 plus anything will give you 1. Obviously, this whole term will become 1. So finally, a into a should be equal to a. So a will be is equal to a. So what is the exact meaning of this one? Even if you put the truth table for this particular expression and whatever the a input you are giving, this particular expression will give you the same result. Can you understand? See how you will prove this expression, or what is this expression exactly means. You have to put a b c and 0 0 0 and 8 number of combinations, and then you have to take this one a b and then a b bar, and then this value, everything you just put separately the truth table, and finally you just find the output for this particular expression. Obviously, whatever the input a you have given, it will come here. That is the exact meaning. So the simplification of this particular expression, which is nothing but it is a. That is the whole idea you have to understand, right? Now what we will do, we will take this one. We will take this one now. So whenever you are going to simplify any expressions like this, see any two terms are common there, so that it will be very easy. See this one here, in this expression and in this expression, BC is a common term, right? BC is a common term. See, this is this comes by practice. So if you practice more number of problems, then you will get good ideas. See, try to understand. So I will take this one, BC commonly outside. What you will get? This one will be A bar and this one will be D bar, right? Plus here it will be D bar, here it will be D bar, and then this can be closed down. Here you see here B C bar is the common term, so take B C bar commonly outside. What you will get? B C bar has gone, so it will be D bar plus D. That is the equation you will get like that, right? So what you will do now, this expression, see here also I have, maybe I would have taken BC D bar commonly outside. Anyhow, see D bar is the common term, so it is BC D bar. Take D bar commonly outside, you will get 1 plus A bar, that is the whole thing, and then plus BC bar. See this one, what is this? Is tautology. So tautology will become what? This term will become 1. So I don't need to write here. So this term will also become 1. Obviously, right? So what is the expression you will have now? This is BC D bar plus BC bar, and the final expression, we have came to the final one. Take B commonly outside. What you will have now? This will be C, and then what is this one? Anyhow, the one more step is that B commonly outside. What you will have? The C bar is there, and then plus this one. This will be C D bar. C D bar. See, try to understand this one. This is very important. Why I'm saying this one? You come here. This expression we have seen. A plus A bar B. A plus A bar B will be is equal to what? AB. This term and this term will be added. Will be added straight away. See, try to understand. Whatever the complementary term, whichever multiplied, will be eliminated. Will be eliminated. The complementary term. That is what you have to understand here. But here, the instead of the complementary term, you have non-complementary term. So what this one will give you, these two will be added. This term will be eliminated. That is the whole idea. That is why I am always saying you, please remember this formula. Please remember, because this gives you very good simplification ideas. Very good simplification ideas. Anyhow, see what you will have now. This can be written as now. These two terms will be added straight away. These two terms added straight away. So this is nothing but this function, this Boolean function, right? So you have to understand. Please you remember this one, a plus a bar b, or term plus a complementary term multiplication of some other term will be is equal to this complementary term will be eliminated. That is the whole idea, right? Right. The next one, see here, this is the expression and we need to prove this expression as y into x plus z. So what you do, see, look into this expression now. This has xy, this also has xy, this also has xy, and this doesn't have xy, right? So three common term in three terms xy is the common. So what you do, you straight away take this xy commonly outside, so that this becomes 1. See, you try to make one particular value to 1, so that the other things whatever added with that will become directly 1. Always you go like that, right? So this is 1 plus whatever it may be, this is ez plus whatever it may be, plus it is ez bar, and then plus here you have x bar, y, and then z, right? That is the idea, that is the idea. So this one straight away becomes 1, straight away 1 plus anything will give you 1, straight away it will be 1. And even this is tautology, 1 plus z bar also it becomes tautology anyhow. So this is xy plus x bar y z. Try to understand. You can directly write here anyhow. See here, what is the thing we have already seen? A plus a bar b will be is equal to a plus b. See here, this term will be inverted here. So if inverted and multiplied with some other term, you can add directly these two terms. That is the whole idea, right? And that is what here you see, this one, this term, the same term inverted. Anyhow, see, I will because I don't need to confuse you, take y commonly outside here. If I take y commonly outside, what I will have? X plus x bar z, right? So this will be like this, and you can see here straight away this term here it is inverted and with some other term. So straight away what I can write here, this is y into this will be like x plus z, and that is this one. See here, we have proved, we have just directly proved, that's all. See, try to understand. See, you can also get it from here to anyhow. I'm not going to confuse you. You do so many problems straight away, and then you will get a good idea how to simplify these Boolean expressions, and you can prove with the left hand side and with the right hand side, right? So the next problem is this one. So first what you do, you just multiply this one, because that is the idea we can go. This is a plus b, a b, a c whole bar plus a b bar c a b, and that is the first term, and then plus a b bar c, and then this is c, right? This is the whole idea. And then you keep this a b plus a c the whole bar plus here a dot a, what it will, see here, very simple, very easy to b dot b bar. This is actually dot, everything is dot, right? Everything is dot. What is b dot b bar? It is fallacy. Obviously this becomes 0. Fallacy will always become 0, right? You don't need to put this expression because this is a fallacy. This is a straight away fallacy. And then you see here this expression c dot c will give you what? C. So this will be a b bar and then c. And what you can do now, you keep this a c the whole bar plus you can take a commonly outside, right? So if you take a commonly outside in both this expression, it becomes b plus b bar c. See here, complement functions multiplied with some other variable, it is coming down, right? So this will be a c bar plus a. This becomes, now you can add these two, right? So this will be b plus c, and now what you can do, you can split this one. This, by De Morgan's theorem, this can be written as a bar plus c bar straight away, right? And then you can multiply this one, right? So this will be ab plus ac, and you can rearrange this one. How you can rearrange this one? So I will write these two terms, that is ab plus a bar. I may write like this, and then this expression plus ac plus c bar. I may write like this, right? And you see here, this is very important. See here, this is a one term, that is complemented here with multiplied by some other term. What I can do? I can add these two, right? Straight away I can add these two, right? What is that one? That is a plus a bar. I can add, sorry. This is complemented. So this term can be written with this one, a plus b, and you see here these two terms are complemented. So what I can write, so this is a bar, right? So this a bar and then this b can be written, complemented function can be eliminated, and here this c bar can be written, and then you see here this complemented function should be eliminated, and I can write this a, See, try to understand one thing. So I will again write it down because so many students will get confused here. This term should be is equal to a plus b. I will explain you again. See here, this is a complementary function, complementary variable. This variable is complemented here. If it is so multiplied with some other variable, you take this plus this. That's all. See here, this one complemented here. So you take this plus this. That is what I have done here. And then you see here, this term is complemented here, multiplied with some other term. So you take this plus this. That is what I have done here. See, try to understand. This concept is very important. And you see here, what is a bar plus a? Tautology. Has came. This is 1, right? Tautology becomes 1. So this term and this term makes it to 1. So you will have 1 plus b plus c bar. Whatever is added with 1, the answer will be 1. So straight away it is proved. This value. That is 1, right? So maybe this is the whole idea, right? So you try to solve these problems by yourself. I will give you the homework to you. So maybe I will solve it in the next class, and maybe we will go to the new topic, simplification of this Boolean algebra. See, what we need to do, we generally have to solve use so many postulates, so many formulas, so many laws to simplify this Boolean expressions. But anyhow, you can solve this one by Karnaugh maths with very simple techniques. You can solve these Boolean expressions, and that is what we are going to start in the next class. Maybe before that we will see these two expressions, right? So you solve it by yourself. I will give you tips in the next class how this can be proved, right? So what are all the topics we have seen in this particular class? See, we have started with the principle of duality, and in principle of duality what we have seen, this OR operator can be converted into AND operator, so that this 1 can be changed to 0, this 1 can be also changed to 0. And we have seen so many theorems, basic theorems, all these theorems we have understood, and this is very important theorem. This theorem will be very useful while solving the Boolean expressions, simplifying the Boolean expressions. And we have taken some example problems, right? So we have taken some example problems, and then we have proved all the left hand side to the right hand side, right? So we will see in the next class.